Welcome to Vision to Venture. I'm Eddie, and I'm here to uncover the realities of scaling and building a tech startup. Each week, I speak to leaders within the tech space with their insights and advice on how to found, fund, and frame a tech startup. So make sure to follow and subscribe to never miss an episode. Hello, and welcome to another episode of Vision to Venture. Today, I'm joined by Dr. Anton Lokhmotov, and from his early days as a lead compiler engineer to a serial entrepreneur, Anton has been at the forefront of driving innovation in AI and machine learning acceleration. Hello, Anton. Thank you for joining me today on the podcast. How are you?
Hello, Eddie. It's a pleasure to be here. Thanks.
It's a pleasure having you. So just to start with, could you just walk us through your journey from being a lead compiler engineer at Arm to becoming a serial entrepreneur in the field of AI and machine learning acceleration?
Yeah, perhaps we should start a bit earlier.
Yeah.
So I first came to the UK 20 years ago.
Yeah.
I was an intern at an American company in Cambridge, UK, where I'm today, still today. And what was interesting is I walked into this office and they said that 95% of software for their innovative processor was written in assembly language. This is practically the lowest level of programming. The lower is only machine codes. And I couldn't understand why. This was early 2000s. And I thought that kind of thing of the past. Maybe in the 60s, maybe in the 70s, you would still do that. But why in the early 2000s? So they explained that their processor architecture was so innovative that if you allowed your compiler to generate code for it, it would be so bad that you probably wouldn't be running at speed, wouldn't get the efficiency. So this actually inspired the topic of my PhD. I decided to look at specialized processor architectures like that. And my passion has always been, not just extracting the maximum performance, but also making it with a least or with reasonable programmer's effort. So I did my PhD in this area at the University of Cambridge. I went to work as a postdoc at Imperial College London. And after that, I started as the lead compiler engineer at Arm, as you mentioned. And at Arm, my role was focusing on compilers. This is basically the topic of my work. This is my passion. So translating things from high-level languages to machine code. And I was working on compilers for graphics processors. So today, many people are familiar with graphics processors used in everything, especially most recently for AI. And back then, it was interesting that we were working on GPUs, graphics processors, designed for mobile phones and small systems, embedded systems. And what was interesting is that that technology at Arm Mali has now been included in 10 billion devices. So this is more than NVIDIA GPUs, right? This is the most prevalent thing people think, but this actually eclipsed by the number of mobile devices in phones from Samsung, Google, and others. So I was at Arm for 5 years. We were working on this interesting processor, but it was limited in a way. When you work for a corporation, you focus on their products. You focus on this one GPU. And my interest was on trying out GPUs from other vendors as well, in the mobile space and then beyond. So I left Arm in 2015 and co-founded the first company, Dividiti. And we were focused on developing an open source technology there. So one of our first customers was General Motors. And back then, 8 years ago, like any automotive company, they were interested in self-driving cars. And self-driving cars would require AI, as we call it today. So you need to use computer vision to see what the road conditions are and decide what to do.
Yes, of course.
So for a company like General Motors, what was interesting is they realized that running AI on processors that we had back then, well, you could see probably pictures of prototypes. You open the boot of the car And then instead of space for luggage, you see a server with blinking lights. So that consumes several kilowatts of power, like several kettles, and turned on at the same time. And there's no space for luggage. So the question was, can this setup be replaced, perhaps with a chip or two hidden somewhere in the bodywork, so that the user of the car has all this boot space for what it is intended for?
Yeah, of course.
Right? So this is how we started. We started looking at AI and ML, and started looking at solutions that could enable that. And yes, GPUs were obviously already existing then, but new solutions began to appear, like tensor processing units. So we started this as a company, and we made it pretty successful, growing this business with clients like General Motors and Arm. And I was doing this 5 years, and then I started my next company, Krai. So you mentioned serial entrepreneurship. Here we go. My serial number is number 2 companies today.
And so I know you briefly mentioned Cambridge University. Reflecting on your time at Cambridge, how did your academic background influence your career trajectory and shape your approach to research and innovation?
So obviously, when you join an academic institution, with 800 years of tradition, like the University of Cambridge, well, you perhaps the world as an academic, right? So you're supposed to write papers, read papers, do some research, collaborate. So as I mentioned, I started this PhD. I was heavily under influence of my previous internship. Mm-hmm. Right? So I already had this collaboration with a company, and I was looking for more. I wanted to do more such collaborations. And one summer I went to a compiler company in Amsterdam. I spent 3 months in Amsterdam.
Oh wow!
Another summer I went to do an internship in Bristol.
Yeah.
With, also a very innovative processor company, and so on. So. Yes, the background was academic, but I probably early on I realized that my passion lies in collaborating and looking for real problems. So a company usually, they have a problem. It's not just purely research. They're interested in practical outcomes, how to make those processes better, or how to make compilers generate code. So. I guess I'm not a very typical PhD student. I was more interested in practical things. So, but still, when I came to Arm, I realized I was still quite academically minded. I was still interested in forging collaborations with universities. And in fact, 2 years into the role, we started a European project led by Imperial College London and then several partners. So Arm was an industrial partner in that, and we collaborated on efficient accelerator programming.
Right.
So I find myself sitting between academia and industry, and this is an interesting fence. You look both ways, and you kind of take the best of both worlds.
I feel like it's the right way to go, because I feel like there are so many people out there that do struggle to sort of figure out what path to go down, whether it is the academia route or the industry sort of route. But yeah, and I've had like sort of several conversations with people in the sort of machine learning field that have been on that fence, the same as you, and have not like sort of known what path to go down. And I can understand why that would be such a difficult choice. But obviously one that one has to make. And what would you say what was it specifically that inspired you to found Dividiti and Krai, and what sort of unique contributions have these ventures brought to the landscape of accelerated computing?
So the inspiration, as I mentioned, was desire to do something practical. So you need to realize that when you work for a corporation, yes, the corporation, the company, they have their own goals. They need to make money. They need to have products. so when you look for doing more innovation, sometimes it can be very supportive. As I mentioned, ARM were very supportive in my participating in this European project. But this is still, a little part, perhaps, 10, 15% of my time, or, Google may call it 20% of their time, where the engineers work on something else, in addition to their main duties. I wanted to focus more, or actually full time, on accelerated computing, and broadly looking for applications of this. Because when you work at a company like ARM, you mostly focus on very low-level things. You need to design this compiler that's going to be used by someone else. So back then, maybe image processing is an interesting one, or a couple of years later, it was AI. So I wanted to be more at a high level, working with applications, and this is what inspired me to make the step out of the door, brave new world, embrace the uncertainty, I guess reflecting back, so you could see that my path was 5 years in academia, followed by 5 years in industry, and every 5 years you need to reinvent yourself. Some people say, and you say, well, I've already done a route in academia and a stint in industry, so the next step should be perhaps one in entrepreneurship. And it turned out to be very successful, finding problems like this benchmarking for automotive. What are the processes that can be used for this task of autonomous driving?
Mm-hmm.
So when we were doing that, so this was literally working with clients, defining benchmarks. So benchmarks are these critical workloads, and at General Motors, they were looking at deep learning and computer vision based on convolutional neural networks. So you define things that you basically say, computer vision in my vehicle is going to work like this, and you define a couple of neural networks, right? So this is your prediction, how workloads of the future are going to look like. And of course, you look at the past or your present. Now, we were doing this, apart from this collaboration with the customer, this was in isolation, right? We didn't have any feedback from other customers. So they felt a bit lonely and at times even pointless. However, we joined a newly formed consortium called MLPerf. So this was 6 years ago. And the promise was that the consortium would define workloads that are relevant to broad industry, not just autonomous driving, but everybody looking at deep learning would get something interesting into this benchmarking suite. So there would be something about computer vision, something about natural language processing, and so on and so on. So we embrace that opportunity, and it's been great.
And so how would you say that your experience as a key contributor to MLPerf shapes your perspective on benchmarking and driving excellence in artificial intelligence and machine learning applications?
Yeah, so MLPerf is a consortium that's now has over 100 members. In fact, initially it was grassroots, and it was started by companies like Google, NVIDIA, Intel.
Okay.
And a couple of years later, it morphed into a non-profit organization called ML Commons. Still, we often use the name MLPerf as to distinguish benchmarking activities from other non-profit activities for the benefits of machine learning practitioners and researchers. So with MLPerf, as I said, we wanted to look at several things. So one is workloads. So yes, we looked at some computer vision stuff. We brought that natural language processing, and so on. Second was methodology. How do you evaluate performance? So the most typical thing in industry was getting maximum performance, maximum throughput. So this means that you have, for example, access to all the samples, right? You need to process, and now we call it offline. It means that you have this sea of samples, images or sentences, and you can use this knowledge, right? And you can optimize infinitely. So, for example, on GPUs, you can select a very large batch size, and this makes the processing very efficient. However, this is not the only mode of operation. In fact, more realistic things in servers is that when you have samples coming over the network one by one, and they come with a certain interval, so they're not available to you at the same time. And this scenario is more difficult to optimize for, but it was critical to understand this is more realistic. And therefore, we started looking at offline server, or in the context of mobile systems, single stream. So you have one sample at a time, you send response back, and so on. So this is the methodology part. Another interesting part of methodology is to allow apples to apples comparisons, right? There are many techniques you can use to optimize your performance, and there are trade-offs. So, for example, you can optimize too much, and your accuracy or quality of your answers is going to degrade severely. So it was important to say, okay, for some applications, there's the boundary of how worse your result can be. So for computer vision, make sure that, so you have this reference implementation, and it gives you 100% accuracy. And now you're allowed to do some optimizations, but make sure that your answers are not more than 1% worse. So they can be off. They can do worse, but not much. So all of that, workloads, methodology, that was very important. And when we started this 6 years ago, workloads were mostly around convolutional neural networks. Then a couple of years later, this shifted to transformers. With transformers, over the last year, we've had additions to the suite around large language models. So this is a very dynamic area, and of course, more companies join. There's more momentum behind it. So every company that designs innovative hardware for AI aspires to run those benchmarks and to show that they perform better than their competitors. So this has become the Olympics of machine learning benchmarking. So definitely, it's been a very interesting journey.
Yeah, absolutely. And I know when you just started your answer there, you mentioned obviously ML Commons. As a founding member of ML Commons, how do you see open collaboration sort of playing a role in advancing AI systems, and what would you say are some sort of key initiatives to sort of that the consortium is currently sort of focused on at the moment?
So collaboration is definitely a very big thing. It's okay. Amazing to see natural competitors in space, coming to working group meetings and collaborating and discussing openly. There's a notion of course, you cannot keep everybody happy, right? It's just plainly impossible. But the idea is that in most areas we can achieve what's known as the graduate consensus.
Okay.
Eventually, people agree, even gradually, and we move forward. So this has been the thrust behind defining the methodology, defining and refreshing workloads, and looking at what new initiatives are important. So in terms of benchmarking, yes, generative AI is a big thing. Obviously, it's of great interest. But I would like to emphasize that ML Commons is not just about performance. I'm a performance junkie. I get high, for getting things faster and faster. But we also realize that you need to keep AI safe. You need to have guardrails. You need to make sure that bad things don't happen. So I'm very pleased that ML Commons have also taken the stance, and there's a working group focused on AI safety. Yeah, and it's just making some initial steps, but I think over time we're going to see more participation and more results coming from this consortium.
Amazing. And so just moving away from that side of things and just to talk a little bit about you, how do you balance your roles as a technologist, entrepreneur, and advocate for ethical AI development? Like what informs your decisions in these areas?
So I think starting from ethical AI development, we want to get AI right.
Of course, yeah.
We will be relying on it more and more in our lives, and it's. I mean, I don't want to repeat some truths, but it is important. That's it. At the same time, I feel responsibility that by using a lot of compute resources for enabling AI, we are probably not doing a great deal of good for the environment. And I think this is where my passion in working on performance and very efficient systems comes in. So we want to enable AI, but at the same time, make sure we use just the right amount of energy, no more than that. And we offset the bad things and with the good things, hopefully. Another interesting area is that I have to balance as an entrepreneur and technologist is well, my time and commitment and focus of my company. So on the one hand, I'd love to feel as a leader of a research group, right? And we are breaking new grounds. We are constantly innovating, working with amazing clients. At the same time, we need to make sure that we have resources to do that. So we have funding, we have paying clients. So we keep them happy, we satisfy their needs first and foremost. And only then we have time for research, and it's an interesting balancing act. But I think over the last 9 years or so, I've managed to do that quite well.
Mm-hmm. It's a lot. I can tell you that. I feel like it's a lot to juggle. But the fact that you've sort of nailed down how to sort of differentiate all the different tasks between the different sort of roles that you are playing at the moment, it's an impressive skill that you've sort of obviously obtained to be able to like know what the important tasks are to sort of put first. And obviously that's a life skill that you can take on for all different types of things, but it's clear that you have managed to sort of really knuckle down and sort of perfect that skill of juggling all of those different things, which is great. And so what would you say are some of the most memorable challenges that you've faced throughout your career? Like how have they sort of shaped your approach to problem solving and innovation? Are there any sort of key moments that stand out to you?
Yeah, it's constantly looking to solve problems. So maybe working backwards from now. So I mentioned this key moment was perhaps being at the beginning of ML Perth, seeing this community sprawling right from maybe a dozen players to maybe 10 times that today. So that's definitely great. I mentioned this interesting moment that working with first customers. So again, when you start your own company, it's not a given that you're ever going to find customers. And being able to land a customer, which was GM was one of the top 10 companies in the world. That was, of course, a huge moment for us, to realize and the importance of the work, importance of the field. Before that, working as a lead compile engineer at ARM, that was interesting. Again, you have a team of technologists, hardware and software engineers, working on this very complex software stack for a very small but a GPU, nevertheless, from understanding what you need to do, from how you take a program and how you convert this to machine code. In theory, right, as a compiler researcher, I knew all that, but when you actually have to go through the process, when you actually have to implement a working compiler, and these are the challenges of taking even the simplest of programs and seeing some output running on the hardware, well, initially on the simulator. And these are kind of victories that you make, and they make you proud. approach to problem solving with an academic view. Yes, you're trying to you set yourself a problem to solve, and you're trying to do this with a combination of some reading and thinking and combination of things. In industry, it's different because you also have you have set limits. You have deadlines to meet.
Yes, of course.
And one of the interesting revelations for me, I guess, was when I started this role at Arm. My manager asked me to provide a plan. How long it would take to see this this compiler producing something interesting. And I guess I said something like 20 months. This was my initial estimate. He said, well, we don't have 20 months. In 20 months, we should already be shipping the hardware. So how about you define how many people should be working on this, and then we bring down the time to make it something more manageable. So this was a critical skill. So trying to estimate the project scope, how long it's going to take, to put, of course, sufficient buffers, because things are never going to take as much time as you hope. Things are not as optimistic, but again, at the same time, not overshoot by a huge amount.
Of course.
So that actually is a very valuable skill that helps me as an entrepreneur today, because when working with customers, we look at the scope of their projects, and it's the same problem. If I'm going to overshoot with my estimates, I'm going to ask for more money, and they may say no, it's maybe too expensive for them. And at the same time, if I'm too optimistic, then it's going to take longer, and still they're going to burn more resources to do that work. So it's not going to be good for business. So yeah, it's another balancing thing, and I'm really happy that I have this breadth of experience from academia and industry to help me on the entrepreneurial journey.
Absolutely, yeah. I feel like you've managed to get the best of both worlds in that sense, and it has definitely enabled you to sort of help with your journey and help with making these different difficult decisions and things like that. I feel like you've got you've got a very long and interesting path that you've taken, but it's obviously led you into this brilliant position where you are now, which is great to see. And based on your experience, I think this is a really great question for you. And that would be if you have any advice that you could give to aspiring entrepreneurs or technologists that are looking to make an impact in the field of accelerated computing and AI and ML. What advice would that be?
Well, I would say that, first is, come and work in this field, because this is very exciting.
Absolutely.
And I understand that when people say that, oh, AI/ML is very exciting, of course, this is everywhere. You see this in the news. You just can't escape it. So why accelerated computing? And by that, maybe we should have defined it in the beginning. But just to reiterate, it's using special purpose hardware or accelerators to solve this problem. And when I started my journey in accelerated computing 20 years ago, it was an oddity, right? I mentioned this company that had to write a lot of code and assembly. In fact, the situation is not that different today. So we have all these innovative architectures, but the main problem, the main stumbling block to adoption is software. And the software might not be in assembly. So we start with computational graphs, we start with neural networks, expressed with a higher level framework like PyTorch. But eventually, all of that, your pre-trained network needs to be translated or lowered into machine code running on this special purpose accelerator. And it has many different stages and many opportunities where things can be beneficial or things can go wrong. So at every step of this multi-layer process, you may easily lose an order of magnitude in performance or efficiency. So it's an extremely difficult problem, and I think we With the current generation of AI hardware, we are beginning to scratch the surface with this. I think companies understand what problems are, and probably it's fair to say that many of them are going to disappear before they're able to solve this problem. However, the experience in these fields will probably help us in the third generation or the fourth generation of AI hardware companies. And I hope that if we have brilliant people coming to work in this field, that hopefully we can make useful progress in the next several years, and then we are going to reap benefits as we can only imagine. So maybe just to give you an example, right? It's very exciting to see text-to-image generators, right? You give it a text prompt and you have a wonderful, wonderful image. Now, this is going to accelerate, and we're going to have text to videos, or not even videos, but maybe even generating virtual worlds where we can work and play. And I imagine this time when little children will be able to have to use their fantasy to define a world in which they want to play.
Yeah.
Now, of course, we are talking about this text-to-image generation, taking lots of resources in the cloud. But if you think that a child may have a device in their bedroom that is able to do this kind of computation and, I don't know, create a nice-looking pattern on the wall, right? So they may find themselves in a magical forest. Or this may be through VR goggles, but without going to the cloud. So that computation has to be very efficient. We have to jump through many hoops, of course, many hurdles to do that. But this will be exciting when we can use this for education, teaching, as well as entertainment.
Absolutely, yeah. And I feel like there's so many advances being made in AI and ML that for children nowadays, it's so much more accessible to get into as well. And obviously that's where it's heading. And so there are going to be give it 10 years, every single child in is going to have some form of AI, and it will be in the form of, like you say, like Vision Pro or some sort of toy or something. It's going to be everywhere. Let's face it, it's just going to take over the world. But now that because of that, it's obviously getting courses in schools and sort of lessons in computer science are now being held and actually are available. When I was in school, they wasn't available in my school, but now they are, which is obviously really great to see. So yeah, I think you're right there. And just to wrap this episode up, looking ahead, what would you say is it sort of excites you most about the possibilities and potential breakthroughs in AI and ML? And what do you hope to achieve in the coming years?
I think, as I described, I see AI being useful everywhere. So in the classroom, helping farmers, grow crops better.
Absolutely, yeah,
agri-tech and robotics. Frankly speaking, who likes doing chores? We have so many of them. You spend time, unloading your dishwasher, loading your washing machine.
If only there was a robot out there that could do it for you.
I know, and it seems to be so far away at the moment, right? And you ideally want that. You want robots to help the elderly.
Of course, right? Yeah, absolutely.
Healthcare. It's so much we could do, right? I would like that to be useful to creative people. I would like people starting their own bands, right? So they can maybe they don't know how to play instruments, but they have brilliant ideas on musical rhythm, texture, right? And they can realize all of that without mastering 100 different instruments. And I'm really curious what people can use in technology for. But personally, what I would like to achieve, well, I would like to have a crucial role building teams that can enable those technologies. right? I'm a technologist, so let's
Yeah.
face it, right? I would like to enable better process architectures to flourish. I would like to make them easier to program. I would like build amazing computer systems that maybe not just built on today's principles, but combine special purpose processing that we use now for AI. They somehow combine other approaches like quantum computing, and all of that, all of that works in harmony, and you don't have to have an army of people programming that. Maybe I describe this right to you as as a tool for creative people, but at the same time, I would like it to guide people, building processes. So imagine if what we could do if a person says, well, I want to build a processor, I want now to build a compiler, and all of that gets generated, created, and then of course, still, you want to make it a social enterprise, really big projects.
Absolutely, yeah.
People collaborate.
Yeah.
Well, that's my vision for the future.
I think you'll get there. I don't have any doubts whatsoever.
Thank you, Eddie.
But I wish you the best of luck to get there. I'm sure you will. You've clearly had a very interesting past and career thus far, and it's clearly going very well. So you're just taking every step in your stride, which is great to see.
Thank you.
But that is actually all we've got time for on today's episode of Vision to Venture. So thank you very, very much for joining me today, Anton. I wish you and Krai the best of luck with all of your future endeavors. And I'm looking forward to seeing what else comes out of it and what you bring to the tech world. So the best of luck with everything, and thank you again for joining me today.
Thank you, Eddie. It's been a pleasure.
Thank you for tuning in to this week's episode of Vision to Venture. If you're listening, make sure to give us a 5-star review. And if you're watching, like and subscribe to listen to more inspiring stories from leaders in the tech space.